Welcome to aminacademy.com. In IGCSE Cambridge International Mathematics Extended, let us discuss about multiplication and division of surds. Look at this example. Root 3 into root 5 plus root 7. Here root 3 can do. Then root 3 is multiplied, those two terms here, that is root 3 into root 5 plus root 3 into root 3. Root 3 into root 5 is root 15 plus root 3 into root 3 is 3. Next example, root 2 into 5 minus root 2. Here 5 into root 2 is 5 root 2 minus root 2 into root 2 is 2. Minus root 5, 1 plus root 5, which is equal 1 into root 5 is root 5, that is minus root 5. Root 5 into root 5 is 5, that is minus 5. Here, then binomial surds with binomial surds, some example. Look at here. Root 5 plus root 2, root 5 minus 3. Here, root 5 into root 5 is 5, root 5 into 3 minus 3 root 5 plus root 2 into root 5 is root 10 minus 3 into root 2 is root 2. Here, there is no further simplification because there is no similar surds here. Root 5 and root 10 we cannot combine, and root 2 also we cannot combine. Next example, root 5 plus 3, root 5 minus 3. Here, which is equal difference of square, root 5 square minus 3 square, which is equal 5 minus 9 is equal minus 4. Next is root 5 minus 3 root 2 whole square. You know that a minus b whole square is a square minus 2ab plus b square. Root 5 square is 5 minus 2 into 3 is 6 root 10, because root 5 into root 2 is root 10, then plus root 2 square is 2 and 3 square is 9, so 18. Then further 18 plus 5 is 23 minus 6 root 10. Next one, we'll discuss the division of surds. Here, express 7 over root 5 into integer denominator, which means denominator should be an integer, not in surds. For this, we have to rationalize the denominator. 7 root 5 multiply up and down, that is numerator and denominator as same as denominator, which is equal root 5 root 5. 7 root 5 over root 5 into root 5 is 5. Now same integer denominator 1 over 3 plus root 2. For integer denominator, here denominator have 3 plus root 2, then its conjugate is 3 minus root 2. So we have to multiply numerator and denominator as conjugate of this. 3 minus root 2, 3 minus root 2. Since 3 plus root 2, 3 minus root 2, you can write a square minus b square form. So 1 into 3 minus root 2 is 3 minus root 2 over 3 square minus root 2 square, which is equal 3 minus root 2 over 3 square is 9, root 2 square is 2. So which is equal 3 minus root 2 over 7. That means denominator become integer. Next example, rationalize the denominator in simplest form, that is 1 minus 2 root 3 over 1 plus root 3. Here denominator have 1 plus root 3, so we have to rationalize the denominator, which is equal 1 minus 2 root 3, 1 plus 2 root 3 into opposite of 1 plus root 3 is 1 minus root 3 over 1 minus root 3. Here that FOIL multiplication, 1 into 1 is 1, 1 into root 3 is root 3, minus 2 root 3 into 1 is minus 2 root 3, minus 2 root 3 minus is plus 2 into 3 is 6, because root 3 into root 3 is 3, into 2 is 6, over 1 square minus root 3 square, which is equal 1 plus 6 is 7, minus here minus root 3 minus 2 root 3 is minus 3 root 3 over 1 square is 1, 3 root 3 square is 3, 1 minus 3 is minus 2. Then multiplying by minus both sides, that means we have to avoid minus in denominator. So flip 3 root 3 minus 7 over 2. Because multiply by minus both sides, minus on both sides, that means minus 7, minus of minus plus 3 root 3 over minus 2 into minus 1 is 2. One more example, 1 over root 2 over 1 minus 1 over root 2. Here numerator have 1 over root 2. Denominator have 1 minus 1 over root 2. So root 2 is an LCM. Then root 2 is cross multiplied. That is root 2 minus 1. So which is equal 1 over root 2 into flip the reciprocal of the denominator. That is root 2 minus 1. This is root 2 root 2, which is equal to 1 minus 1 over root 2 minus 1. Now rationalize the denominator, that is equal 1 over root 2 minus 1 into root 2, opposite is plus 1, root 2 plus 1, which is equal root 2 minus 1 over root 2 square is 2, 1 square is 1. So which is equal root 2 minus 1, 2 minus 1 is 1, which is equal root 2 minus 1. One more problem. Look at here. Find the value continued square root plus 2 plus 2 like it's continuous. That means continued square root. How to solve this? Let x equal to the given things. 2 plus 2 plus 2 plus 2, like this it goes. Now squaring both sides. We have x square equal, for squaring this outside square root will vanish. This square root will go. The remaining things we have to write 2 plus 2 plus 2 plus 2, continue. Here which is x square equal 2 out plus this already the same as the given original, so that expressed as x, 2 plus x. Now combining x square minus x minus 2 equal to 0, it's a quadratic equation. By solving quadratic formula by using this x equal to minus b, minus of minus 1 is 1 plus or minus root b square, minus 1 the square is 1 minus 4, a is 1, c is minus 2 by 2 into 1, which is equal 1 plus or minus 1 plus 8, because minus 4 into 1 into minus 2 is minus 8, which is equal to 1 plus or minus square root of 9 over 2. We'll take the positive square root, that is 1 plus root of 9 is of course 3 by 2, which is equal, therefore x equal 1 plus 3 over 2 is 2. For a continued fraction of square root of 2 plus square root of 2 plus square root of 2, it goes continuous. Its values is 2. So its value is 2 here. So far we discussed about inserts, division, multiplication and division, and some example problems.